I was trained as a chip guy, so it's a real pleasure to be out here talking to embedded system developers. We've pivoted the company around this entire trend of the Internet of Things, and it's very, very exciting. I was born in 1967, 2 years before we put man on the moon. And almost to the day, I have a picture of myself sitting in front of a TV, watching the men landing on the moon. But the technology that was developed by my father's generation, the semiconductor, the integrated circuit, computing, communications, since then has pervaded the economy, has pervaded society, and really transformed the entire world. If you just think about, where we are today, we've got our smartphones, which mine is off, and there we're always connected. We have access to virtually unlimited information. We have access to the cloud, to apps, and we're really at this inflection point. We're at this inflection point where that same technology, that connection, and all the benefits that have accrued from that are going to get applied to everything else in our lives. And so it's all these smart connected things. The Internet of Things is getting ready to happen in a big way. And so there's a lot of different things that are coming together right now in terms of how this is going to be applied, how the engineering is going to be done. And that's really the focus of my talk. So I think it's really useful to talk kind of about how we got to where we are. I grew up with one of those wired phones. And it was really exciting when we got push buttons on the phone. And then I actually worked at like a radio store, and we sold back like in high school, and we sold these big Motorola analog phones. And then it moved into, GSM and all of these different things. Blackberries, and now today are smartphones. If we really look at how those have evolved, and like what's really changed over time, you've got the fact that the network has grown. You've got the fact that the connectivity has gone from wired to wireless. And I think that's very important as we look at the Internet of Things, is are we going to run 10 billion wires a year? And also the functionality has evolved. So I'm going to dig into this a little bit, and then we'll zoom back out to some more details. So in 1975, we were 230 million global subscribers, and it was just you called, somebody was home, they had to be home, and that was a lot of people. If you look in 2005, we had 3 billion connected devices. And in 2001, the number of mobile phones exceeded the number of wired phones. And if you look really into 2015, now there's nearly 7 billion mobile devices this year. Half will be smartphones. And that number is dramatically larger. So today there are more connected devices on the planet than there are people, and we're just talking about phones, not all of the other things. Really, and then if you start looking at the connectivity of the phones, we talked about it being wired, we've gone to analog, to 2G, to 3G, to 4G, to LTE, to local area networking like Bluetooth and Wi-Fi technology. And so you've got multiple radios now integrated inside of these devices, and they've evolved to faster data rates, while at the same time, being able to operate off the batteries and all of that stuff. And you've got multiple radios optimized for different purposes. The Bluetooth is optimized for one thing, the Wi-Fi. You use those in everything else. Really, so if you talk about, how the number of devices has increased, and the fact now that you're wireless, the usefulness has gone up. The fact that you've untethered them means that you can do a lot more stuff. You've also got the functionality of the devices that's increased. So this is really enabled by Moore's law. The fact that we doubled the number of devices on a semiconductor every 18 months or so, and the RF and mixed signal integration. So all of the different functions that are inside the phone now are really enabled by that trend. And this has enabled us to have more computing power in that phone than got the man to the moon. And so you've got all the sensing. You can connect and access all of this information. You can track your activity. You can figure out how long it's going to take you to get home, and just the amazing amount of functionality and the evolution of that over time has really made these devices much, much more useful. So the functionality of the devices is increasing, and now you've got this connected to the web, so the smartphone. And now this really brings us to the Internet of Things, where you connect the phone, you connect all these devices through a network to the cloud, and really now you have this entire ecosystem. I have got another video here from Bill Morelli. He's one of the analysts at IHS doing research on the Internet of Things. And he's going to talk a little bit about the different applications and the size of the market and the growth of the market. So please listen.
The important thing to remember about Internet of Things is it's a conceptual framework. It's not a specific technology. It's not a specific device. So it's really about this philosophy of being able to embed the connectivity and share data across multiple devices and the value that that can bring. Where we see the growth coming from and where we start to get into what we call the Internet of Everything is where you have this delta between devices that are connected today and devices which are becoming connected. So that would be things like streetlights or fire hydrants, kind of novel use cases for connected devices. And that takes you from having a device that is inherently connected to devices where you're really adding the connectivity and creating a unique value. So if we look at this growth trajectory from where we are today with a market like smartphones, where you saw that quickly grow, very quickly grow from one smartphone per person to now maybe 1.5, 2 smartphones per person in most developed markets, we actually expect to see a much faster and larger ramp up with Internet of Things. One of the reasons being that you have so many connected devices per household. So per individual, it may not be a 1-to-1 or 1-to-2 relationship, but it could be 40, 45 connected devices. For 2014, we estimate the market's about 19.7 billion devices. And that's across all of the different markets in terms of installed base. So that is counting all the smartphones in the world today, all the tablets in the world today. The growth, though, that we expect to see is by 2020, an installed base of 53 billion connectable devices. And by 2025, that's actually going to grow to 95.5 billion connectable devices.
Well, I know that I'm doing my part to have, drive this number up. But you can see that IoT is really getting into every area of our lives. And if you really look, kind of just break that down into the different markets. Actually, maybe a show of hands in the audience. How many people have more than 20 devices in their house or that they own? This would probably be, you guys, how about 10? 10? Wow, you guys are behind. You got to. We need to sell more chips up here. But so if you look at where we are today, you've got about 40% of the things are smartphones, which are in the communications category up there, and then the computing is the tablets and PCs. So about 40% of that is there. Then you've got a large consumer number, everything from TVs to DVD players to Blu-ray players, and then there's a large industrial component today, and then you have medical and automotive type applications, which are maybe lower volumes, but also have a higher value. So let's look at kind of what happens over the next 5 years. You see that PC and the computing part, the tablets and the PCs and the smartphones, going to only about 20% of the IoT. So you have a large growth in consumer devices. It's not just going to be large TVs, it's going to be do-it-yourself, lots of different things, and a huge growth in the industrial area, which is very broad, lots of different applications in like these man-to-machine type of applications. So we're going to take a look at some of those real quick and just go through to give, everybody's pretty familiar with this, but just kind of a flavor of what's going on. So you've got, the connected home we're seeing a rapid rise in the connected home in terms of that market really coming together, the operators, cable companies, TV companies, internet providers, mobile companies, as well as retailers rolling out these types of devices. You've got things like climate control, resource monitoring control, fire, security, remote access, keys, lighting, appliances. There's a lot of benefits that accrue by connecting these. You could, for instance, take your appliance and you know how it's going to age, or you can tell if something's wrong so you can send out a repairman or something like that. But this will help us reduce cost, reduce energy usage, improve convenience, comfort, improve the quality of our lives. And this is one of the main drivers that we see today coming out into the Internet of Things. If you look, energy is also it's actually one of the most critical areas of the future of the world. And It was really one of the early drivers of IoT, all the smart meters for electricity to do load shedding and those sorts of things to prevent having to build another power plant to avoid peak power. But if you look at just energy globally, it's about 20% of the global economy. It's about 10 trillion euros. And luckily, I don't have to convert euros to dollars. It's easier these days. But I'm sorry, bad joke. And you look, about $2 trillion is spent just on electricity production alone. And if you think about the quality of people's lives, you think about global warming and all of those things, we've got to become far more, not only do we have to have alternative and green energy and all these different kinds, but we've got to become far smarter in the way we use energy. And so the metering, turning things off and on, optimizing energy usage in both the supply chain, in terms of supplying energy and gas and water and all of these things, it's just going to have a huge impact on reducing costs and improving utilization, and ultimately in the productivity of our economy. If we're going to keep the global economy growing, I think this is one of the key areas. Being from Texas, and I can break into my Texas accent if you'd like, but we always have to have a cow picture. But there are, just as an example, you've got 1 billion cows in the world, and so you'd like to know where they are, you'd like to know if they're healthy, you'd like to know if they're reproducing, and all sorts of things. If you think about farming and crop yields and the cold chain of moving, food from the farm to the stores and keep making sure it stays at the right temperature. The IoT, the connection, the sensing, the control, all of that really comes into play. Very interesting area, especially for a Texan. You've also got infrastructure. You've got, cities, smart cities. You've got, things like, you can monitor bridges, and see if they're stressing or moving or something like that. So you can, you have lighting, you have traffic signals, you have smart parking sensors. When you go to the parking lot, you can see exactly where you would park. And so there's a lot of things from an urban infrastructure, building automation, a lot of different things that create value. One of the favorite topics probably here in Germany, factory automation. Smart factories have been a long-term trend. It's kind of, maybe one of the early aspects of the Internet of Things, really, the automation of our factories, sensing and monitoring things like temperature, pressure, humidity, flow, proximity, lots of different things in the industrial control process, and also controlling, robots and valves and motors and contacts and relays. There's a lot of different aspects of the factory to help make our factories more efficient, automated, and enhancing the productivity. You've also got the supply chain. We talked about, the cold chain, but also you've got, just logistics and retail and where's the shipping container? What's in the shipping container? What's going on? That whole concept of asset tracking and optimization of the supply chain is another large area of application for connected devices. Certainly health and, the medical cost in the world as the world's population ages. My parents are 87, and they, you kind of wonder what's going on with them. So, keeping track of what they're doing, all the health and fitness monitors, all the wearables are really hot right now. Everything from smart watches to fitness trackers, heart rate monitors, all the sensors that go with that, all of the low power type aspects. You can start to see that a lot of these applications are battery powered and are wireless, very much like the smartphone, but start to look very much different. Probably another area very popular here in Germany is transportation. They're connecting the car completely. It'll have an LTE modem and it'll have a Wi-Fi hotspot. I'm not sure if that's good or bad. We've got autonomous vehicles, all the sensors that go into that. The fact, navigation, safety, performance, so much about the car, about being monitored and controlled, and also the diagnostic capability of that. But the connected car is definitely a wave of the future and an important area of IoT. This looks a lot different than smartphones. This is this is not just Apple and Samsung. This is tens of thousands of companies and thousands of different applications. And it's a broad market. So, it also kind of means that as engineers, we've got to think a little bit differently. Really, there's kind of a new paradigm about what the Internet of Things means. And we talked about the market, about how that's different, but really, how are the devices different? They're different in functionality, They might be, we talked about man to machine. They might not have a user interface. They might have a limited number of sensors. Broad range of applications of that as well. The connectivity is different. If it's wireless, it's working off of a battery. Might have to be a little different than a smartphone. And certainly the energy available to a lot of these applications is going to be less. And then you've also got the integration level. If we're going to sell 10 billion, are they $600 a piece? Are they $1 a piece? There's going to be a wide range. But there's going to be a different optimization. Really, if you look at the trade-offs that are involved between energy consumption, functionality, the integration, the cost level that's going to be there, the connectivity that gets integrated, and how that would work in a smartphone, and that's where a lot of these technologies have been developed, that over time, it's going to change. You're going to have solutions that are really maybe smaller or have to work on a lower energy budget or have maybe it's not connected very often, have a low duty cycle or, again, more limited amount of functionality. But I think a lot like the smartphone, this is going to also be impacted by Moore's Law. Is also going to change as time goes on, and you're going to have more functionality for the same amount of energy. You're going to be driving the cost. You're going to be increasing the integration level or the number of sensors. And so it's kind of like that, but it's not really the same. So I really want to kind of focus the talk in here on kind of the engineering part of IoT. And it's really, there's like three fundamental challenges. You've got the energy efficiency, and we'll talk in more detail about why ultra-low power is very important. You've also got the connectivity, and then you've got the integration, and then this whole concept of simplicity. How do we address the broad market in this broad range of applications? So we're going to dig into this a little bit more. And so first we're going to talk about energy efficiency. And these IoT devices are going to have to be designed from the ground up as ultra low power. They have to be energy friendly, and you've got to get the maximum amount of functionality. So let's talk about we're going to talk about batteries and how much current and how this changes compared to the smartphone. But first we've got a video from Ger Fora. He was the founder of ChipCon and the founder of Energy Micro. Here's Ger talking about lower energy.
Over the next 10 years, battery technology and battery-operated nodes will be key. It's hard to envision that you will have tens of billions of nodes out there where people have to change batteries very, very frequently. And then we are talking less than microamp total energy consumption in these modes to really gain 10, 15, 20 years battery lifetime on a small coin cell battery. On top of this, is that these devices are going to be more and more complex. There's not only one sensor. You may want to measure humidity, and you may want to measure temperature. You may want to measure proximity. There are tons of new things that is coming to make these more advanced, and that adds to the burden of really making a really low system energy consumption. So it's not one single thing that you need to achieve, but a number of things that needs to come in place when it comes to energy consumption for this to evolve to tens of billion devices.
So back to my smartphone. It always feels good when the battery is green, when it's like 100% and you get it off. But when it kind of goes down like that and you've got 10%, you're starting to look for a charger, right? And that usually happens at about 3 p.m. Depends on how many emails you get. But if you really think about how that compares to what's going to be available for one of these IoT devices, I don't think you'll want to. If you're going to have 45 devices in your house, you don't want to charge them every day, and they're not all going to be hooked up to a wire. We saw what happened with the phones. They're not all going to be hooked up with wires. And a lot of them are going to be these, like a little coin cell is 220 milliamp hours, the CR2032. And if you want that to last for 5 years, you've got about 5 microamps average current, which is not much. And you can take 20 milliamps out of a coin cell battery, maybe 50 if it's a larger version or something. But it's a limited amount of current that you can pull both from a peak basis and certainly on an average basis if you want that battery to last even 5 years. And so that really constrains it's really the energy efficiency is the key to the IoT and making it work. And what functionality can you get from this limited amount of energy? And you're going to want more functionality over time. And you've still got to communicate. You've still got to do wireless. If we're going to we're going to get rid of the battery, you're going to have even less energy available. Maybe microamp or less. It won't be reliable. And so this whole concept of pushing things down to very, very low energy consumption is incredibly important. And you've got to do things like, have low active current. You've got to have very, very low sleep current where you're not, when you're powered down. You've got to have things like that are processing the sensors autonomously. You don't want to power up the microcontroller just to take a measurement and see if something has changed. You want to have a lot of smart autonomous operation of these devices and very, very low current. And over time, you'll be able to do more. The sensors are going to get smarter. The sensors are going to get lower power and all that. But this is really the fundamental, when you're looking at building a system, as chip designers, this is what we're really looking at. How do we optimize energy consumption is really the core piece of success in this market. Really, the other piece is connectivity. And the connectivity has got to be, optimized for low energy. In the phone, you had LTE or, the cellular modem. You've got Wi-Fi, you've got Bluetooth, and then, there's a lot of proprietary stuff. There's Zigbee, there's Thread. There's a lot of different types of protocols. So I'm going to step through these pretty quick and talk about kind of the, what are the strengths and weaknesses of all this, and how is this all going to play out when we're starting to talk about the Internet of Things. So let's start with Wi-Fi. Wi-Fi, we all have that in our house. We all love it and hate it at the same time. But it has pretty good range. It's a star network, so in general, things talk to the access point, and I have to have a couple access points in my house to cover the whole house. So it's not really a mesh network. It's certainly not low energy because you got hundreds of milliamps to transmit power. These are not going to. That coin cell won't work. So you got to have a bigger battery, or and then you got to have very low duty cycle. It's not going to work very long. But you got IP connectivity, and that's a very familiar technology for us. There's efforts to move this to to lower energy levels, but it's very challenging when you have to do these linear PAs. And really, Wi-Fi is optimized for high data rate type of applications. Just to talk about IPv6 real quick, so IPv4 is a 32-bit address, which gives you 4 billion devices. So we've already got more than would really be able to be individually addressable. So IPv6 uses 128 bit address, and I can't convert that to numbers because it's a really long number, but it's certainly large enough for what we're trying to do. The next one is Bluetooth, and you've had Bluetooth Classic, that's evolved into Bluetooth Smart, and Bluetooth Smart is really optimized for low energy. Android and iOS now are supporting that. There's a lot of activity in this, but it's a very short-range technology, usually very, very low power, optimized for the coin cell again. They're starting to develop mesh networking, but to be able to bounce from one device to another, but that's not really baked into the standard yet. We talked about the low energy, and they do have IPv6 coming along. So the key advantage of Bluetooth Smart is that you can talk directly to the cell phone. It's not really a networking technology yet, but it is used to talk point-to-point between devices. And so that's a big advantage. If you want to talk directly to your smartphone, you can also talk to the cloud and talk to the smartphone, but that is a different way to go. So Zigbee, so based on 802.15.4, ultra-low power, optimized wireless mesh network. You can get very good range. You can have higher power levels, lower power levels. You can have some that are power, have a wire connection and not. The mesh network. You've also got, some level of IP support in the Zigbee protocols. There's efforts to improve that, but that's really it's mostly not an it's got its own addressing scheme. It's not an IPv6, and IPv6 has a lot of advantages in terms of the software stack and reuse. And then if you look the development of Thread, which is again based on 802.15.4. And there's been a consortium of companies, a lot of activity in this area using standard type of technology to develop an IP-based, low energy optimized with privacy and security, with mesh networking, and to have the longest possible range. So this is really optimized for, both Zigbee and Thread are both optimized for fairly low data rate. And a lot of the types of applications that we're talking about, it's very little bits of data, maybe very low duty cycle. So these types of networks are very appropriate for that. So I've got a video that the president of the Thread group, Chris Boros, wanted to share a few words about kind of, the motivation for low power wireless networking.
So I think existing wireless protocols designed for the connected home space, many of them were developed a long time ago, before, basically in a previous era of computing, where we didn't have smartphones or tablets, or always on internet connections. And I think those protocols were designed for basically a different set of use cases. Now people want to build a different style of connected product, and I think they need a more modern protocol for that. I think that devices have to be connected by a network that's very secure and very reliable, and robust, and use mesh networking to deliver that. I think it has to be very low power as well, because we want to be able to build products that are battery powered with years of battery life. And for the end user, it has to be extremely easy to use as well. IP addressability is very important all the way to the end node, because it allows end nodes to communicate with each other directly, and it allows you to reuse software stacks, which is a huge thing when you're developing a product. Software is, in a lot of cases, a massive development to get software working on these devices, and being able to reuse software between different types of nodes on the network is a really great benefit when all of the nodes on the network just use IP stacks. I think IP makes an awful lot of sense in mesh networks in the connected home space, but it also has applications outside the connected home space in commercial and industrial applications as well as neighborhood area networking. I think that most wireless mesh protocols will head towards IP in the near future. I think the benefits really outweigh the disadvantages in terms of what IP-based mesh networking can bring to these types of networks. And I think as Moore's law is allowing you to cram more processing and more compute into the radio silicon that you want to embed into these products, it makes IP, the case for IP, stronger and stronger. Thread was always designed to work with Wi-Fi networks in the home. It's not a replacement for Wi-Fi. It's designed to augment Wi-Fi and bring IP connectivity to devices and use cases that can't necessarily use Wi-Fi in the home. And the same goes for Bluetooth as well. Both Wi-Fi and a new version of Bluetooth carry IPv6 communications, as does Thread. And we actually see IPv6 as a convergence layer that runs across all of these different networks in the home.
So if we look at the connectivity in the home, you've got, and this really applies to, I think, all different areas of the IoT. You're going to have a variety of different wireless protocols. I mean, you see in the phone, you've got 3, 4, however you want to count it, but all the cellular standards, and then Wi-Fi and Bluetooth, and then those aren't really optimized for low power. So there's really going to be a number of different areas. You've also got a number of proprietary. There's a lot of backward compatibility and all that. But we see, the IoT, the standards and the coalescence around these various different ones. If you start to look at some of the characteristics, you've got Wi-Fi up in the 5 gigahertz and the 2.4 gigahertz band, optimized for higher bandwidth, higher data rate, maybe somewhat limited in range. In Europe, a lot of the buildings are made of steel and concrete, and so the high frequencies don't really penetrate through the buildings very well. You've got Bluetooth, working at the 2.4 gigahertz band. You've got Zigbee and Thread currently working in the 2.4 gigahertz band. There's a lot of talk about those moving and also supporting some of the sub-gigahertz bands. And then you've got a lot of the proprietary stuff done at sub-gigahertz. Things like wireless M-Bus is a standard, but there's a lot of proprietary things, and that backward compatibility is also really important. How are you going to support these legacy modes while at the same time evolve to more standards? So there's a lot of really interesting stuff going on in wireless, and that I think really impacts how the types of chips that you want to embed into the device and make sure that they're scalable over time. So that really brings us to integration, and I have to forgive, or you have to forgive me for putting one of my favorite diagrams up. And the coffee stain and the pen were were added later. But I did draw the diagram there. But this really kind of brings it all home. So if you think about a smartphone, that outer box is not there, and each one of those boxes is a chip, or multiple chips. You've got, in the Apple, the A8 processor that is optimized, in its, process technology, Moore's law, as fast as you can go, the most processing power. You've got memory, you've got RAM, you've got a flash chip. Those are in different process technologies. You've got a radio, a front end, you've got PAs, separate modules, filters, lots of complexity at the front end, supporting all these different bands, antennas, energy management, typically in an older legacy type of process, a more than more process. Then you've got all the sensors. You've got the gyroscopes, and you've got the accelerometers, you've got the touch controller, you've got the display. All these are separate devices. The Internet of Things, for the most part, is going to be where all this has to go onto a single chip. And that is different than the smartphone. And so you've got this RF integration, you've got power, you've got optimized power, energy consumption, you've got processing power, probably ARM is going to be in most of those. You're going to have embedded flash memory. I mean, we said that these devices need to power up very, very quickly. And you have to have optimized sensor interfaces. You have to potentially have some mixed signal integration for the control, maybe some external components there, depending on what type of device. But fundamentally, these need to go into into the same process technology, go onto the same chip, be driven in terms of the integration level, both from integrating all of the external components. And it's like a microcontroller with a radio, right? So it's different than, most microcontrollers today don't have radios in them. The radios that are out there are in different technologies, but that's all got to converge into a single chip that's really highly optimized. And you're going to have multi-bands. You're going to have to support sub-gig. You're going to have to support 2.4. You're going to have multi-protocols. You're going to want to support your legacy modes and all that different stuff, while at the same time having extensibility into Thread, Zigbee, Bluetooth, Wi-Fi, all of these different standards. And so, when you're out there looking at solutions, you got to really look at it's not just the specs, but it's the extensibility, and the devil's in the details on all the energy consumption. And there's so much clever stuff that you can do to save power in the design of the circuits, as well as the implementation and in the software. And it's really, really, really exciting. The important thing is, again, this is like microcontrollers in that it's not just one chip, right? You're not going to do one chip. They have to be general purpose to span this broad range of applications. They have to integrate the right functionality. It's going to be a bunch of different processor cores, different memory configurations, different sensor interfaces. I mean, we talked about, tens of thousands of different applications that this has to go into. So really, this whole concept of simplicity really matters. It's got to be easy, but it's also got to be scalable. If you look, you've got to have this portfolio. You've got to have a scalable platform, both from a hardware perspective and a software perspective. So it's not just the one chip, it's multiple chips. It's all the software development kits. They have to be modular. You've got all the wireless protocols, all the stacks. All this stuff has to work and work seamlessly. You've got development tools, to be able to simplify building applications. And it's got to be both microcontroller. You've got wireless in there now, and how does that all get integrated in? How do you make that easy? And then you've got to be able to get from prototypes into production. You've got to have, kits. You've got to have modules. You've got to have, go through certification. You've got to get it into, a CM. You've got all the RF complexity. How do you deal with this? This is, a lot of the people that are implementing these things for the first time haven't done that before. And so you've got to be able, as, a supplier, but also, as engineers, we've got to figure out how to integrate this stuff in a simple way, in a way that's going to really help us get to market as quickly as possible. So I think you can see that there's a lot of different aspects of these devices compared to where we were with the smartphone, and also compared to where we were when we weren't connecting things. And so it's a really exciting time. So, we've got 2015, here we are at the beginning, and you're supposed to end one of these things with some predictions. So, and you try to be as controversial as possible. So this year you will expect to see dramatic reductions in energy consumption. We've, the cost points that we're going to be able to hit, driving Moore's law down, getting the integration of the radios. There's just a lot of effort at getting these platforms together across the industry, and that's going to be really cool. If you look, you've got the low-power wireless connectivity, the deployment of these. Bluetooth Smart is here, Thread is here, Zigbee is here, low-power Wi-Fi is coming, and that is, those are going to be widely deployed, and there's going to be multiple standards in multiple areas, so you've got to be able to be fluent through that. But I think that these low-power connectivities standards like Zigbee and Thread are really going to start seeing broad adoption. I mean, we've seen dramatic increases in terms of the numbers of units shipped to those standards and the deployment of those in the retail and the operators in a lot of different places. And then these IoT SoCs are here. You've got microcontrollers, you've got lots of wireless devices, you've got various levels of optimization and integration, but they are here and they're evolving. This is not going to just change, it's not going to be static. We're going to have a continuous evolution of the integration, the size, the cost, the functionality, the energy consumption that we see over time. So, I kind of hit on this, that it's a really exciting time to be an engineer. There was, I don't know, maybe 5 or 6 years ago, and I was like, I'm a chip guy, and you think, God, all the low-hanging fruit have been done. We've integrated all this stuff. We know how to do RF. The cell phone is commoditizing. What is the industry going to do? And then you start to think about, oh, well, this technology is going to be put out into the market in a totally different way and spread out across these broad range of applications. It's not just Apple and Samsung. And I apologize to the Apple and Samsung guys in the audience, but it's everywhere, and it's changing the world. I mean, the impact of this trend and making things smarter. Think about, I can't imagine living without my smartphone, and 10 years ago, we didn't have that stuff. And I think that the way the world is going to get smarter, the way our lives are going to get better, the way our factories are going to get more efficient, the way we're going to deal with the energy crisis, what we're all working on as engineers is going to change the world. And it's going to make our society better, it's going to improve people's quality of life, and it's going to make our economy more productive. So it's a fun time to be alive and to be an engineer. I'm going to be around for a while if anybody has any comments, but thank you.